we really didn't do a whole lot. It was just because half the class was like making ERDs, and then the
Yeah.
other half of the class was like, she called it SQL. I don't know because it
Okay.
was using Oracle.
Yeah. So SQL is a standard, so that's perfect. SQL is a query language. That's perfect. So I'm just going to assume that most folks have some exposure to databases. So when I say something like insert into a table, it's not going to be completely foreign. All right. So one of the things about Python, and I just realized my mic was muted for the last 30 seconds, but that's okay. So because now we're going to get into the fun stuff. So we're going to integrate with a database. There is a Python database API. So it is a specification within the Python programming language that is how you interact with databases. And the way Python does it is you'll use a database driver, like a MySQL driver, which implements that interface. So you can interact with a MySQL database the same way you would interact with Oracle, or the same way you would interact with Postgres. What we will be using today is called SQLite, SQLite, SQLite 3. It is a local disk-based or in-memory based relational database. We won't have to install Postgres. We won't have to install MySQL or anything like that. We'll just use this open source database technology, SQLite, for some examples. And in real life, this is used. I have statistics on it later. But for this, it's good because you don't have any real external dependencies on your application. So, but as we go through this, whenever we talk about SQLite, know that the same things apply to other relational databases. And in Python, it follows that DB API specification, which will make it compatible. So when we interact with the database within Python, we have a couple steps that we have to follow. And these are going to sound awfully similar to when we dealt with files. So we'll create a connection, which is essentially opening a file. So we'll make either a network connection, or in this case, a connection to a file on disk. Then we'll get what's called a cursor. That's how we interact with the database. Then we'll execute commands, whether it's queries or updates or inserting data. We'll commit our transactions, and then we'll close our connection. And just like our files, we always close our connections because we don't want too many open handles on our database. And when we start talking about databases, that gets even more critical, because if you think most environments, you have a centralized database. Like if you are at the company you work for, there's probably a centralized set of databases like Oracle or MS SQL Server that a lot of different applications will use. And so if every one of those opened 35 connections to the database and never closed it, you can harm that centralized database. So it's even more critical here that we always close our database connections. So it's kind of an abstract concept until we actually see it in code. So let's look at it in code. But before we do, database connections, queries, and all that kind of stuff are typically the slowest parts of our applications. So we've talked about sorting. We've talked about how you can sort efficiently. Our big O notation on how we can process a large data set in less time. Any processing you do on your local CPU is usually faster than your database connection. Usually. Not always, but usually. Most things we would do in an enterprise software environment are external connections like a database or an external API. Those are always going to be the slowest part of our applications. So we need to take that into consideration when we design applications to only do that as infrequently as needed, make sure our networks are fast and all that good stuff. But we'll talk about that over time. All right, so the code is going to it's going to start like this. So SQLite 3 specifically is a library within Python. It's part of the base Python distribution. You can find all you want to find out about it at SQLite.org. But it's built around a C language library to be a small, fast, self-contained, highly reliable, fully featured SQL database engine. It is It is the most used database engine in the world because you can embed it in any application. Old mobile phones, modern mobile phones, anything. Your dishwasher might have a SQLite database in it. It's entirely possible. It is such a lightweight engine that you can use it anywhere. The file format is stable, cross-platform, backwards compatible, and the developers plan to keep it that way through at least the year 2050. So if you build any application around a SQLite database today, you'll retire by the time it's done. So that's kind of cool. This is the part I really liked. There are estimated to be over 1 trillion SQLite databases in active use. Trillion. So, while it is local, while it is file system based, while there's not an external installation of a robust database engine, it's pretty darn good. Okay, cool. So, now the actual code. So we import the SQLite 3 library, and then there's a function called connect that we use to create a database connection. In this case, I am creating a connection to the database in a file called example.db. That file name can be anything. You can actually do it in memory without an actual file. There's a way to do that. We won't do that today, but you can. But it's that simple. If the database exists, this library will open it, and you can use an existing database. If it does not exist, it will create it, because it's just a file on the file system. So the exact same thing happens when we open a file to read or write in our other Python code. So SQLite3.connect, and then the name of the file that the database will be stored in. That's what you need to make a database connection. That's our step 1. Our step 2 is to make a cursor. The cursor is the thing we use to interact with the database. And from there, con, which is our connection, con.cursor. Easy enough. Cursor is a function on the connection object, and I'm putting it into a poorly named variable C for cursor. From C, now is when I can actually start doing things with the database. So in this example, I'm going to create a table. If you're familiar with relational databases, everything is stored in a table. So I'm going to create a table called stocks. On that table, I'm going to have 5 columns. One is a text column called date. One is called trans for transaction, also a text column. Symbol, text column. Quantity and price. So data types, there are different data types in the different database engines, so it gets a little weird here. But it's smart enough to know if I'm going to do a text, or when it comes and maps this back to Python code, a text data type becomes a string. A real becomes a floating point number. And that's all I'm using in this case. But we have dates, we have integers, floats, strings, binary, blob kind of stuff, all kinds, whatever data structures you're used to having in a database engine, you can put in SQLite 3. And so we create the table and we execute that on the cursor. So the cursor has an execute function, and I'm going to pass in the create string. It's a SQL command. If you want to learn more about databases, I have recorded all my Info 610 classes. They're on YouTube. You can watch them for free. Have fun. But for now, I'm going to assume you can pick this up really quickly. If you have questions, as usual, interrupt me and ask, please. Next statement, I'm going to insert data into that table. So I'm the format of that is insert into stocks being the table, insert into the table name, the values, and then a comma separated list within parentheses of the values I want to insert into that table. So in this case, I'm going to put the 2006-1-05 into the date field, the by string into the transaction field, R hat for Red Hat in the symbol field. So imagine stock market symbols. The quantity of how many stock shares in this case I'm buying, and I guess the price at which I am buying them. So I'm buying 100 shares at $35.14 a share. So I'm inserting that into my newly created stocks table. I must commit my transaction so it actually gets stored in the database. And then I close my connection. And voila, I have interacted with a database and I've inserted data into it. So that data is now permanently stored into a database file that any program using the SQLite library, whether it's Python, C, Java, it doesn't matter, can now interact with the same database file. It's kind of cool. Any questions here? I went through database interactions very quickly, but hopefully you picked it up. And if you didn't, ask questions.
You said it was poorly named variable for your cursor.
Yeah.
What would be a good example of a cursor name?
It could have been cursor. It could have been CURS. It could have been, just in general practice, a single letter variable name is not a good idea. Unless you use it like in a for loop or something and you just have to have a counter, then it's okay. But in general practice, it's not a good idea. Although this is from the Python documentation. I'm appalled. CONN is a little better, but not great either. But that's okay. That's not the point. So before we get into more, so for SQL, we can query, we can insert, we can update data. To insert data, I use the insert statement in this general format. Insert into the table, whatever columns I want to insert and whatever values I want to insert. Then to query, I select some columns from some table or tables. I can where to filter, I can order by, I can do all the SQL things that I want to do. From your 364 class, hopefully you remember some of that and it's kind of familiar. Select star from stocks gives me every column for every record in the stocks table. Select date, comma symbol from stocks where symbol equals MKL will give me all the records, but only the date and the symbol column from the stocks table where the value of the symbol field is MKL. Bonus points if anybody knows what MKL is. One of the Fortune 500 companies in Richmond.
Markel?
Thank you. Yep, Markel. One of the few actual stock symbols I know. Updates and deletes, we can do that later. Not that important for tonight, but there's an update statement and then there's a delete statement. So if we look at our database, or if we look to create a database for the movies that we created, or the movies in that CSV file, I wanted to make this real and important, or not important, relevant. That's the word I'm looking for. I wanted to make this relevant to the things that are important in this database. I'm not putting in the tags. I'm not putting in the adult flag. I'm putting in the things that would make sense to us. So the ID, the title, the original title, the budget, homepage, etc. So I picked 11 columns here, and I'm going to start making a database table that has those columns. So here I am doing so. So I'm going to create here's my SQL statement that I would execute. Create table, movies, and in a comma separated parenthetical list. I'm creating an ID, which will be an integer, and a primary key. A home page, which will be a string. You'll see here I used varchar. The other example was text. There's a slight difference in what those mean, but at this point in time, they actually may get mapped to the same thing within the actual database engine, but you can use either. It's the same text field. IMDb ID, whatever the ID is from IMDb. A release date, I'm going to use an actual date column. The revenue of the movie, the runtime of the movie, the voting average of the movie, and the vote count of the movie. Remember those columns from our CSV that we looked at last week in Jupyter Notebook. So Now if we start talking about software design, we like to modularize things. We like to put things in a context, like there's a word called cohesion. So you put the things that are relevant to each other in a single function or a program, that kind of thing. So in this case, I'm going to create 4 different programs. Well, in class today, we're only going to build 3 of these. I'm going to create one program that will create the database. It's going to be very, very simple, but it's going to initialize. It's called initialize.py, and it uses the SQLite 3 library. It's just going to create the database file and then create that table in it. So that's kind of step 1. Step 2, I'm going to insert the data from that CSV file. So here I know I'm going to interact with the database in that CSV. We don't have to use pandas, but we did last week, so let's use pandas to load that CSV. It's going to make life simple enough. And again, I'll use a SQLite 3 library. Then we're going to go another step further and make an API from it. So this is where we're going to start talking a little bit about API design. And when we looked at those Flask routes last week, I'll show you how we will actually use them to get relevant data. And then eventually we'll make a client to do the same thing, but that's not tonight. So can everyone picture this in their head, having 4 different applications that do 4 different things, and each can run independently of each other? Easy enough. Cool. All right, so here's what initialize.py looks like. I'm going to import the SQLite 3 library. I have a function called create database. I have a function called create structure. And I have my main method. Going to software design again. The reason I'm breaking these into different components. Again, cohesion. I'm doing different things in each of these functions. So I'm breaking it down. I'm saying, okay, I'm gonna isolate the thing to create the database. I'll have one function to create the database. Then I will have a function that does obviously creating the structure. But you'll see here it's dependent on, or has a function, or has a parameter that we'll get from somewhere else. The reason we do that is, if we think about Python, and we're not a strongly typed language, I can pass in a SQLite 3 connection. And I know it will work because it has a cursor function and it has an execute function. Or, well, the cursor has an execute function. But the connection object in this case, it's from the SQLite connection class. It has a function called cursor. Now, if I wanted to test this will actually create, both of these functions will create an actual database file. If I wanted to test this, I would do something called mocking, where instead of passing in a real SQLite 3 connection, I could pass in something else that has a cursor function, and that cursor that gets returned there has an execute function. For purpose of a test, like a unit test, it doesn't matter if it actually creates a database file. I want to make sure it is calling those functions correctly and can behave on the responses. And so in my tests, I can mock it so sometimes it throws an error. Sometimes it's successful, sometimes it doesn't respond, sometimes it, whatever. That'll give me a lot of ways I can actually test this function. So that's why the SQLite 3 stuff is actually isolated and in another block of code. So anyway, going back to the function. So in my main method, I'm going to call that create database function, and I'm passing in a file name where I want my database to end up. In this case, I've hard-coded it to database.sqlite3.db. And the return value from that create database function is that connection class, or the connection class. Then using that connection, I can call the create structure next. And then that create structure makes a cursor. I have a string variable called create SQL. And in there's the create table, movies, ID, etc. that we looked at before. and then I execute it against that cursor. And when I'm done, I close my database connection. So when I run this program, Python initialize.py, it runs. Doesn't give me any output. I don't have any logging or printing in there. And then on my Mac or on a Linux machine, there's a program called File, which tells you or guesses what the type of a file is. So after I initialize the database, I can run file against database.sqlite.db, and the file program says, yes, you have a SQLite 3x database last written using SQLite version, whatever. That's internal stuff that the database driver needs to know, so when other programs open it, it can say, ooh, am I compatible with SQLite 3.x version 3028000? But that's all that function does. It just made a table in the database. When I was doing this earlier, I forgot to call the create structure function. And so after it created the file name and I ran file, it's an empty file. There's literally no data in the file. So the actual SQLite file is an empty file until something happens to it, like you create a table. That's just an FYI. I think I've linked to all of the code examples here on the slides, so if you want to get them and look at them, you are welcome to. But any questions about this? Super quick, initialize py file. All right. I did this one on the command line on my computer. I did not use Jupyter Notebook. I didn't use Anaconda. I'm using another environment manager like Anaconda, but it's called pipenv. Python. It's a very standard, popular dependency management software. Anyway, you can do the equivalent with Anaconda, but I did here with pipenv. So I installed it on my Mac. I have Homebrew installed, so I could just do brew install pipenv. I create a virtual environment for Python 3. I move into that virtual environment, or activate that virtual environment with shell, the shell parameter. And then I install my dependencies. So pipenv install numpy and pandas, because I know I actually didn't need numpy because pandas is dependent on numpy, so it would have gotten installed anyway. That's what dependency management does. And from last week, we found we had 3 lines in the file that kind of break things. So I removed those 3 lines again. And to do that, I just opened it in a text editor, found the strings, and removed that line. Right? Everybody remember we did that last week? Cool. All right, so here's what my load data function, or my load data application is going to look like. I'm going to start at the bottom this time. I'm creating the data frame by reading the CSV, using pandas, read the CSV, movies, metadata.csv. And now I have a movies data frame. I want to insert every record into my database. This is the least efficient way of doing it, but it works. So I'm going to iterate on each of the rows in that data frame. So the data frame has a function called iter rows that allows you to iterate. You get a k as the index. So this is the 0th line. This is the 100th line, etc. But I wanted a dictionary of the row, and that's what the row or the second attribute is there. And then I made a function called load row. Load row is the thing that actually interacts with my database. So in that load row function, I create my database connection. I create my cursor. And then I create an insert statement in SQL for SQL. Does that look like any SQL statement you've ever seen before?
Yes.
It does.
Like the insert into movies and then the ID, title, original title, like that looks really familiar.
Okay. What about the end of it?
Like the question marks?
Yep.
No, I have no idea.
Okay, good. I'm going to say y'all know more than I thought you did. But that's good. I'm glad you don't know that. Because otherwise, like, half of tonight's lesson is pointless. Just, no. What we're doing in this statement. Okay, if any of you ever do a job interview, and there's any coding questions, and they ask you about software vulnerabilities, okay? I don't know if you will or not. I teach a class at Capital One about this concept, so it's fresh in my mind. The most popular, by far, the most popular software vulnerability from a cybersecurity standpoint is called SQL injection. Has anyone heard that term, SQL injection?
I think so.
Okay, another popular vulnerability is called cross-site scripting, or anyway, there's a bunch of them. Like, the most popular is called SQL injection. What happens in SQL injection is, if you imagine you have a website with some form on it, and you type in a username and password, if your code is written badly, the input from the user ends up getting processed by your database engine as if it were SQL. So you've seen the joke, Johnny drop tables or whatever like that. Kids named Johnny drop tables. There's a great comic on this. It's hilarious to people like me. So here we go. This is a XKCD comic on SQL injection. Hi, this is your son's school. We're having computer troubles. Oh dear, did he break something? Well, in a way. Did you really name your son Robert drop tables students semicolon hyphen hyphen? Oh yes, little Bobby Tables we call him. Yeah, we've lost all the students' records. I hope you're happy, etc. And I hope you've learned to sanitize your database inputs. That's the key. What happens is if I'm concatenating strings and I put in this ends up making two SQL statements in one SQL line, and the drop table command gets executed against the students table in this case. Anyway, the way we get around that is we use what's called query parameterization. And so when I write my query here, I'm writing it in a generic form. I'm not building this SQL statement with the movie values in it. I'm using these question marks to say, and a value will go here, and a value will go here, and a value will go, etc. We don't know what those values are when I make this string, but we know there will be a value put in there. And so when we call that execute function on the cursor, the first thing we pass in is the SQL statement itself. In this case, it is a parameterized SQL statement. The next parameter is everybody remember what this data type is? There we go. It starts with a T and ends in a tuple. My pastor does that all the time, so I had to do it. Anyway, this ends in tuple. Okay, this is a tuple. So the first item in the tuple is the ID attribute of the movie dictionary, which was the parameter to my function, which came from my data frame. So the data frame movies has a lot of movies in it. I take for every one of those movies, I temporarily call it row and pass it to my load row function, which essentially aliases it as movie. Then when I call my SQL execute, I pass in attributes from that movie. So you see how I backtraced where that movie dictionary came from? So whatever was in the CSV through all this stuff is going to get put into my SQL statement. So every record in that CSV will become a single record in my database. So when I go and I run this, Python load data.py, I eventually get an error. Can anyone explain to me what that error means and why I got that error? Let's see how good your 364 professor was. Someone said no primary key. Not quite. Try again.
Some primary key got repeated.
Yes. The value in the primary key tried to be duplicated. So primary key is must be unique in the database. The value for a primary key must be unique in the database, in the table. So if we looked at this data, actually let's look at this data. That's the other class. Um, 13 source movies metadata. All right, so we see the 1, 2, 3, 4, 5, sixth column in this CSV is our ID. So if we look at Toy Story, I have my is not adult, belongs to this collection. Collection. That's the description. That's the line. And I'm going backwards. There we go. I think, yeah, that's the ID. So in this case, I have a value of 862. If I try to insert two records with the same value of 862 in that ID field, it will fail. Because I'm trying to, or because I'm violating the unique constraint on that column. So here I have a couple of options as a software and data engineer. And I put it on here. So I have violated unique key constraint, tells me the source data. So this tells me, as I'm running this, that the source data, that CSV file, the ID field isn't really a primary key. So there may be some duplicates. There may be some other attribute like release date or version or something that like in combination makes the primary key. So first step of data analysis, I have to understand my data. So a couple of ways I can do that. I can identify what if there is really a primary key in that table. And it may be a composite primary key across multiple columns. Or I could shortcut it and make my own new primary key, making like a UUID or a globally unique identifier, or just have an integer counter or something. There are lots of options I could do as a data engineer. But because I was being lazy, I just said ignore it. So if I get that exception while I'm loading the row, I just ignore it. And I'm just going to print out that there's a duplicate. So I looked at the actual data. The first one I looked at was truly a duplicate. It was the same record in the file twice. The second one was different movies. So for the purpose of this class, I didn't really want to go and fix it. So I didn't. So I just ignored it because I wanted the rest of the data to execute. So let me go and run this code up to this date. So I already have the SQLite file, but I'm going to remove it. And I don't have it anymore. So I'm going to run my initialize function. And now I have my database SQLite3.db. Now I'm going to load my data. So Python load data. This took me, I think, 30, 90, 60 seconds, something like that. Here's where I'm printing out that, yes, I got a duplicate primary key. I'm not terribly worried about that. Again, I'm just ignoring it. If this were something critical, like something at work, if I were doing financial records, if I cared, then I would have to analyze my source data and find out what the heck was going on. In the end, I think there's 20 or 30 duplicates in this whole table. There are tons of rows in this table. All right, so now we've created the database structure. We've inserted a ton of data into it. Now let's get the data out of it. So I want to start querying this data and showing what the code to do that looks like. The reason I'm doing this is going to teach us a few things for our API project that we are building. Things to know when we build APIs. We will have a function that happens when a function that gets called when the HTTP request occurs. You know, we had those route defined of like hello world or whatever. It was decorating that function that get called when that route was queried. So keep that in mind. In the end, we need to have these functions get called in our code. So we're going to organize this code like that, even though this is not going to be our Flask code yet. So I made a first query.py file, and this is what it looks like. Import SQLite 3 and logging. Same get database function that we had before. And then I have a function called query rows. Yep. Create the connection, get my cursor, and here I'm just going to select star from movies, limit 5. Limit 5 says just give me 5 rows. I don't care which ones. Just give me 5. I don't want 53 million. Now, what we didn't do before, which we're going to do now, is here I'm going to assign the results from the execute function into a variable. When I'm creating the database, I didn't do that. Let me get to that in a little bit. Don't let me forget that question. It's a good question. So I'm going to save the results from my query. So when I create the table, if I don't get an exception, I'm going to assume it worked. When I'm inserting records, I could get the results. I could make sure it inserted one record like I wanted it to, all that kind of stuff. But I didn't in my code. But here, because I'm requesting some stuff out of the database, I definitely want to capture the results. So the execute function returns a result on a query. And I can print that out. I'm going to print out the type of that just to show you what it does. And then I'm going to iterate on that result. So that result object is an iterator, so I can use it in a for loop. So for movie in result, I'm going to print the type of the movie, because I want to show you something, and then I'm going to print the movie itself. I don't have to commit because I didn't change anything, so I actually could remove this line of code, and then I'm going to close my connection because we always close our connections. So let's look over here. So you see those all got inserted, that many duplicates. Cool. So if I execute first query.py, it is this code exactly. All right. So going line by line, go away. Oh, crap. I scrolled on the wrong window. Okay, there we go. So the first thing I print is the return value from the execute function. So here, that is a cursor object. So the cursor gets returned, or a cursor, the cursor, I don't know. A cursor object gets returned. And that's when I print it. So there's a str function on that class that gives me like a string representation of it. I'm going to use the type function in Python to see what the data type of that is, and it confirms it is a SQLite3.cursor. Then for each movie in the results, I'm going to print out the type of the movie and the movie. Again, the string representation of that movie. So if we look at all that output, I see it's returning a tuple, and the values in that tuple are this. 862 looks like an ID, title, original title, budget, URL, IMDb ID, if I remember correctly, release date, revenue? Was it revenue? I don't remember. Average rating, number of ratings. No, that's not right. What's that one? Runtime. So an 81-minute runtime. Revenue was the one. Yeah, revenue, runtime, average votes, number of votes. So whatever this data set was only gave Toy Story a 7.7. So this is not a valid data set. Fake data. Because Toy Story was one of the best movies ever created by any movie theater company ever. That is a fact. If you disagree, drop out of my class today. Seriously. I don't care if it's too late. All right. Anyway. Where was I? Toy Story was a great movie. So that's what happens. So here's, that's what comes out. We just did that. So the return type is a cursor. I can iterate it, and we get a set of tuples. Tuples are great immutable data types. But if I wanted to get the title of the movie, in this example, to use it in a formatted string, I can do this. This is not a formatted string. This is a string that I call the format function on. Similar difference. But I get the first attribute from that tuple. So how do we know which index in the tuple will be which field when we select star? I don't know. We guess. Python second query. So found title Toy Story. So if I look at that, see here is where I'm pulling out that first index from the tuple. Do you see what I mean when I say, I guess? Because I didn't say select ID, comma, title, comma, whatever. I just said select star. So I have to figure out what order the columns are put in. Is it always the same? Maybe, but I'm not totally sure. So I'm not a big fan of this, but it works. So now I can print out things like just the movie title. All right. But I want to fix that or change it. So in my third query.py, I want to change what's called the row factory. So the default row factory gives me a tuple for each row. If I use the SQLite3.row in my, let me start that one over. The connection object has a row factory attribute. I can assign something like this. SQLite3.row is a row factory. This row factory allows me to use the column name when I'm getting the data out. The execution of this one is a little slower, maybe, but it doesn't matter. For most things we do, it doesn't matter. Now I can change my query definition and not change, even if it changes the order of those return values, I can still access the column by title. I'm sorry, by the column by attribute, column name. So query, whoops, what do I call it? Third query. Python third query. So output's the same. So I like this better than that. Okay, so on the insert data, we parameterized the insert. We parameterized the query. What I want to do now is I want to add parameters to this query statement. So here I'm just selecting star from movies, limit 5. Let's parameterize that. So if we go back to thinking about our API, maybe this API will power our moviefansite.com, or we make something super awesome and IMDb wants to use it as their API that powers their website, whatever. We build an API to power the website or power something. If you imagine something like Netflix, let's go Netflix, that's a good one. We have a search bar. I can type in a keyword in my search bar, hit search, and some movies will come up. That's a search by the title. They probably do searches by title and actor and genre and all this kind of stuff. But let's limit it to title. So we're going to search by the title. After I get my search results, I want to click on one to get details for that one. Is that normally what we do on Netflix, right? Maybe? Yes, no? Somebody? Anybody? Yeah, that's what we do on Netflix. So the first thing we do is we search by title. The second thing we do is we search by ID. Your video is the only one up, so I see your cat, so it distracts me. Hi, kitty. So let's show what that looks like. This is a lot of code on one page. Actually, I think I'm going to move this one over to code, VS Code. Code filter. I think this is my filter. Oops, nope. .py. There we go. All right. Oh, that's not it. Code filter items 1.py. There we go. Can y'all still see this okay? Okay. So here, go away. I'm changing up my dictionary row factory. I'm going to create my own row factory. So I'm actually defining, this is what a row factory implementation looks like. It's a function. The first parameter is a cursor. The second parameter is the row, whatever the row is. Anyway, the thing that comes out of that SQLite3.row factory is it's a pseudo dictionary. It's not really a dictionary. It just kind of lets you get things by attribute. Here I'm making an actual real dictionary. So I have my own dictionary factory function. I have my get database connection function. And here's how I'm going to search by title. So my search title function has a DESCR description parameter. So I want it to be a string. I'm going to return a list of movies. So I have a return value that I will return at the end of the function. I get my database connection. I get my cursor. And if you know SQL, I'm going to take my incoming description string and surround it with percentages. So I can do a substring match within it. So if I type in Toy Story will come back. And excuse me, and then my function looks, or my query looks a little bit different. Select star from movies, where title like parameter. Like is the keyword or is the operator we'll use to do that that string match or that substring matching. And again, I'm going to limit 5. So I execute that, passing in the string parameter. Now, when you do this, and you only have one placeholder in your SQL, I can't do c.execute select query, comma, parameter. I can't do that because that second parameter, the second required parameter to the execute function must be a dictionary. No, I'm sorry. Must be a tuple. Okay, so let's make it a tuple by putting parentheses around it, because that's how we create a tuple. Well, Python doesn't actually see that one as a tuple because there's only one attribute in it. I forget what it sees it as, but it's not a tuple. So you kind of have to force Python by putting in a comma, even if there's no attributes afterwards. I'm saying, seriously, Python, this is a tuple. So that's why it looks like that. All right, back to where it was. So I get the result after executing that query for movie in result. Results.append movie. Remember, that's a dictionary. I'm committing closing.